Hello everyone, welcome to week 5 of IS 688. This week we'll be starting module 3, looking at similarity, dimensionality reduction, and hashing. The announcements for this week primarily concern module 2. The module 2 assignment has a notional deadline of this week, so hopefully you have had some thought about what you want to write for the second module assignment and have some idea about putting some words down on paper about using graphs and analyzing graphs from the web. There's code for this online. You can check it out at GitHub, as I've mentioned in the past. Also, since we're starting Module 3, the Module 3 assignment is now available. So primarily we'll talk about or deal with the metrics of similarity and how you can assess similarity. We'll talk about this week and next. The overall idea for Assignment 3 is to develop different ways of defining similarity and then measuring distance between elements in some data set based on whatever similarity metric you choose. So the main thing here is you need to create or extract or use some pre-existing data sets. This is different than the previous two assignments where you had to build your own data set. Here you can take something from Kaggle or from some other space. It's already been built for you. And then define or identify how you want to featureize this content. This means identifying what constitutes features. Are they words or usernames? Are they domains that are shared? Are they image embeddings or something like that for a given set of query entities? So here you need to identify 3 different query entities and then evaluate what are the elements in your data set that are most similar to these 3 query entities based on the similarity metric and featurization approach that you've chosen. So, as with all the medium assignments, you need to start off with a strong motivation or problem about how these rankings are important or what problem you're trying to solve by providing somebody these rankings. Then I want you to discuss where your data comes from and how you're going to featureize it. We'll talk about featurization this week when we get into shingling and a number of other things. And then I want you to describe how you determine similarity. What does similarity mean in this context and these features? And then for each one of your 3 query entities, identify 10 of the most similar items in your data set. And then show their ranking. So you should have 30 different 30 different items ranked, 3 sets of 10. And then as with every other assignment, what software did you use? Give any examples of bugs you identified and ran into, include figures, these kinds of things. And that's due October 13th, so that's 2 weeks from today. Some examples that you can look at I've included here, like ranking web pages by similarity in the graph, like we talked about last time with SimRank, looking at subreddit data from Reddit and which subreddits are most similar to each other based on domain shared or usernames who appear in both, ranking Twitter users by similarity based on hashtags or words, or movies based on similarity of actors or genre, etc. So there are a number of different ways you can define similarity, a number of different data sets you can go look at. And the idea is to define some sets or some definitions or create some definitions of features, similarity, and how you're going to measure distance here. Fortunately, Python has a very nice library in sklearn for handling distance metrics of various kinds. So you can essentially, once you have your feature set, throw this distance metric library or this distance metric code at your data set, and you get back your distances. I will note, though, you should be careful about the size of your data here. When you build this distance metric, it gives you back a matrix. This pairwise method gives you back a matrix of distances between all pairs in your data set, which means if you have n items in your data set, you're going to get a pairwise distance matrix that's n squared in size. So you can very easily run out of memory using the pairwise approach here if you are not careful. And we actually will talk about that this week. That's it for the module assignments. The next thing to talk about is the semester project. All of you have your feedback. I've talked with each team about what that feedback entails. If you haven't already, you can submit a revision addressing any comments or issues that I brought up in your feedback. The next thing for your project, though, is the data collection report. So that's due next week. That's a hard deadline. So be sure and I'll be working on that. The primary thing here, you don't have to have all of your data collected. You don't have to have everything sort of set in stone, but you need to have some pipeline in place for how you want to do data collection, have some idea about where you're going to collect data, and have something working that shows you've collected some data, you're storing it in some particular format, that you've dealt with these kinds of questions. And you need to have this done regardless of whatever revisions that you've submitted. So that's it for the project. This week we have a few main learning objectives. The first is we're going to talk about a number of different metrics for measuring distance. You need to be able to identify 3 of them, and then we're going to talk about featurization in text and how we can use this process called shingling to take a document or a web page and turn it into a set of features based on the letters in the document. And then we're going to use that to evaluate similarity between documents. You can do this other ways using words as well, like your standard bag of words approach, which I'll talk about. But shingling is a pretty straightforward method that has nice bounds that we can use. The third thing is to be able to describe the relationship between Jacquard similarity, which is a similarity metric for comparing sets of things, and the min-hash approach, which lets us create these measures of similarity in a more efficient manner. And then number 4 is to explain the intuition behind locality-sensitive hashing. Where is it useful? Why do we need it? For instance, the n-squared pairwise distance matrix problem that I mentioned a few minutes ago about size, LSH, or locality-sensitive hashing can help us there. As always, there's a module discussion forum. You can post any questions you have. So that sort of sets the stage for the things we'll talk about this week. For next week, we're going to dive into dimensionality reduction. So you need to read chapter 11, sections 11.3 and 11.4 on singular value decomposition, which is a good example of how you might do dimensionality reduction. Then you should be thinking about, as I said, Module 2, getting the assignment for Module 2 up on Medium, and be thinking about the data collection report, which is due next week. Now also assignment 3, as I mentioned, is due in 2 weeks, so you should be thinking about this as well. If you have any questions about any of this, you can feel free to reach out, post in the discussion forums, or come to my virtual office hours on Thursday.